The Omni arch is designed to clean the front bumpers, rocker panels, and wheels of the vehicles. It's got the ability to flip twice through a computer function to follow each wheel. A couple of important features on the Omni are the oil bottle and the flow control valve, which controls the speed at which it turns and follows the vehicle's wheel in the pivot position. Also the flow control at the back of the cylinder, which adjusts how fast it returns home to get the next car or to get the next wheel. I'm going to simulate the motion of the Omni, and then we'll watch and see how we adjust the screw to see how it changes the speed of the pivot point. Every time that solenoid valve gets energized, that Omni is going to flip. The speed at which it flips is being controlled by this Parker flow control valve. If we turn it counterclockwise to the left to take it out, it'll follow faster. If we turn it in, it'll turn slower. We can see how slow it tries to turn. Okay, and that would be for an extremely slow chain speed, or if we really wanted to flip it slow over a certain vehicle. If I open it up while it's spinning, you'll see how it immediately speeds up. So the whole idea is to try to balance the speed at which this is turning to the speed of the conveyor. The reason we use this valve is it's color-coded. Once you set one side to the speed at which you want it to follow the wheel, you can look at the color code. If you're showing all blue, you can go dial the other one into all blue, and they'll both match each other. They'll both flip at the same speed. You don't have to sit there and get wet trying to make your adjustment on the other side. The valve that's on the back side of the cylinder, we usually keep open almost all the way. That way there it'll flip and return home quickly to get ready to do the next vehicle. So it flips slowly, following the wheel, and then return home is quick, right back so it's ready for the next vehicle. And again, this one here, we set this one just showing the blue or the green, whatever color we had on the other side, and it'll flip at the same speed, and they mirror each other. Again, the oil bottle is designed just to make smooth motion so it follows nice and smooth under pressure. If it gets contaminated, it can be changed by shutting off the air, releasing the fitting here, letting the oil drain out, pulling the plug, and adding new oil to it. Always needs to be done with the air turned off and the air bled off the system so there's no pressure on the unit. The unit is built with no grease fittings. It's all UHMW plastic. There's nothing to grease, nothing to service on the machine itself, other than the nozzles. The nozzles that are down here, if they get clogged, whether it's from reclaim or dirty water or contamination in the tank, they need to be taken off, cleaned out with a small tip cleaner, and then reassembled and put back together again. Okay, the hydraulic flow control in the power pack adjusts the speed at which the motor spins, which is very slow to fast enough to get full coverage on a high chain speed. Revolutions here kind of vary depending on how fast the car is going, how much coverage we want to get on the wheel. At this speed here, as we watch it operate, we'll get at least a couple dozen revolutions up and down, oscillations up and down on each wheel as we pivot and follow. Same thing trying to hit the bumper and grill. If we're not getting the coverage we want, sometimes all we need to do is speed the motion up with hydraulics and get a little more coverage, a few more passes at the wheel or at the bumper to get the cleaning to be the way that we want it. Two nozzles weren't spraying clean. Slide them in the holes to dislodge whatever is in there. And then looking through them to make sure they're clean. Can be reinstalled. Good idea is to have another full set of nozzles on hand. So when you want to do maintenance, you can take them out, put in the new set, clean your other ones, check them for wear, replace any bad ones, and put them back on the shelf ready to run again. Because this is a front wheel pull conveyor and our nozzle or spray pattern was just above the rail, we're going to loosen up this bar here and actually pivot the pipe down a little bit so we get full coverage on the wheel. So in order to adjust the pipe, we need to loosen the clamp, loosen this nut, Then using either the pipe, this wrench here is a lever, we can pivot it down a little bit. If we go too far, to bring it back a little bit. What we're looking for with our rotate our hydraulic motor so we're in the straight down position, looking at our angle here to make sure that we're just above the rail. And then we're down enough to do that. And we tighten up our clamp. And then we'll turn our pump back on and see if we get the same penetration. So now we're just above the rail. Okay? We get full coverage on that wheel. One of the adjustments we want to make sure that we have maxed out all the way is the pivot and the distance at which it'll follow the wheel. It's a 6-inch stroke air cylinder, so we want to make sure that we adjust the stop so that we pivot the basket as far as it'll go without deadheading the cylinder, either on the extend or on the return. Send it back the other way, Bubba. Loosen up our bumper stop. Run it in a little bit further. Energize the flip valve again. And we can see here that at this point here, we're not against our bumper, but we've deadheaded our cylinder. So we run the bumper back out till it touches the basket. Push the basket off a little bit. Extend the bumper another, say, 1/4 of an inch. And then lock that in place. And now we have, pivot again, now we have our maximum stroke. On the other side, you can see that we're fully deadheading the cylinder, and our bumper stop is just touching. So energize it, please. On this one here again, we're going to push this out a little bit. Bring it out just about a little less than 1/4 of an inch. Tighten up our bumper stop. Return it. Ended. We know we're not deadheading because we went to deadhead and adjusted our stop out on the other side. On the return, we know we're not deadheading because we still got a little bit of silver shaft showing. Just 1/8 of an inch, which is all we need to keep that shaft from being deadheaded against the inside of the cylinder, but still give us full stroke. To clean the strainer, which needs to be done periodically depending on the environment that we're in, close the water valve off here, then unscrew the bowl, let the water drain, and in here our strainer has done exactly what it's supposed to do, is catch most of the contaminants and bugs, debris, anything that's fallen into our tank. To clean that out, we're going to rinse out the bowl. Rinse out our strainer. Get all the contaminants. Also rinse out the bowl. This should be weekly or more often if need be with reclaim water. Important things to look for when you change the filter and clean it out is to make sure that the O-ring doesn't leave the bowl. The O-ring needs to stay intact. The screen gets put back again, set solid on the bottom of the bowl itself. Then aligned up properly, screwed on, not overkill, just snug. Then reopen the valve. Make sure that we don't have any leaks. And the pump's ready to run. Now, the maintenance on this filter here varies by location, varies in what atmosphere you have in your tank, whether you're outside, inside, in the equipment room, or in the tunnel. Also whether you're running reclaim or not. Some areas it'll be once a month if it's all fresh water. Some areas will be daily if it's running reclaim, and the reclaim is, running a different, a high degree of solids, high micron content. Okay. Both of them need to be serviced at the same time. You can see the difference now between this one and the other one. To adjust the pressure, you need to loosen up the locking nut. Loosen up the locking nut. Turn the regulator in so we watch the gauge increase. Needs to stay running smooth the way it is. If we were to cavitate, we'd have to run the pressure back down to 0 and come up. 600 pounds right here.